So, hello everybody. My name is Aviran. I'm head of engineering for Wix.com. And today, what we're going to talk about is how to transition from a monolith, basically, to a microservices environment, and the road that we at Wix took about 6 years ago. And some of the lessons learned during this road that we took. But before we start, I mean, how many of you are already doing microservices? How many want to do microservices? Not yet? Okay. Okay, so a little bit about Wix for those of you who weren't attending yesterday's session. Wix is a website builder platform. We allow our users to build websites and manage their small businesses. We have about 95 million users. Those are the website builders that are using our platform. We manage about 2 petabytes of data for them because we're doing all the hostings, running in 3 data centers, plus the 2 major clouds, handle about 2 billion HTTP requests per day. And we have about 4 R&D centers in Israel, here in the Ukraine. We just opened a new one in Kiev, and we're trying to launch it in in a month or 2. But these aren't the numbers that we're here to talk about because you don't care about those. This is the number. I mean, Wix is running about 250 microservices currently in production. And when people hear about microservices in all the talks, you hear a lot of buzzwords like throttlers and how to monitor it, and SLAs and circuit breakers and feature toggles and testing and DevOps and boundary, a lot of things that you have to take into account when you're thinking about implementing a microservices architecture. But the first question, and a lot of you raised their hands that they said, well, we want to do microservices. But the first question that you need to ask yourselves is actually why? Why would you even want to do microservices? Because it's a hype, because everybody is talking about it, because that's the latest trend. Why? Can anybody give me an answer? Why do you want to do microservices? Independent deployment? Yeah, independent scalability. So basically, you have scale. Microservices, the best thing that it comes to solve is a scaling problem in different aspects. It's scaling engineering. If you have a lot of microservices, you can create teams a lot of teams that are independent and can work on different services. You can scale your deployment velocity, increase deployment velocity because you're decoupling, the architecture is decoupled, and a lot of teams can progress in parallel. And you can scale the system much easier. If you have one big monolith and just one part of it needs to scale, if you don't have microservices, you actually have to scale the entire monolith with the databases, like huge systems. So microservices is the first post-DevOps architecture, and it's coming to solve a scaling problem. So the question is that right now, let's say we don't have microservices. How do we get there? Okay, so Wix didn't start with microservices. And this is the story about the journey that we took. So let's go back in time, to the beginning of time, about 6 years ago. Wix was a monolith. It was a giant monolithic application that had everything from user login, sign up, editing websites, viewing websites, BI. Everything was in just big, huge monster. And we came into a point where our deployment just took like 3 months of every version, and deployments were very tough, and the system was unstable, and we couldn't scale not the system and not the company, not the engineering. So, and remember that was around 2010. Microservices wasn't invented yet, the term microservices. And to tell you the truth, the microservices it's kind of a hype, it's kind of a bullshit word. It's basically software-oriented architecture. It's just done right. So what we did is we thought, okay, this is the time to start breaking the system apart, because we wanted to scale the system. We wanted to scale parts of the system in a different way. We wanted to scale our engineering. And it's not that easy breaking the system, because the first thing that you need to understand is, how am I going to do it? How am I going to break the system? What parts should I take out? And we took a look and tried to analyze, okay, this is the product that we have. And we said, okay, what do our users do? What are the distinct operations, and what is the differences between different parts of our monolith? And we were looking about the concerns, the operations, the activities that our users are doing, and the different scalability concerns, the different SLAs that we can define to our systems. And there are basically two parts to WIX. In every system it's different. I'm telling you the WIX story. This is how our system is built. So when we see what our product is doing and what our customers are doing, I mean, they're doing two distinct things. One is they're building the website. They're coming to WIX, they're signing up, they're going to the editor, and they start building the site. Once they're done, they click publish, they publish the site, and then you got all the viewers, all the people that are on the internet, they're coming to view and enjoy their just newly created websites. And we saw that there are distinct things for those two different activities. First, we saw that there are many features requests on the editing side. The viewing part is kind of stable. Just, okay, send you the HTML. This is how the site, go and look and view it. In terms of performance, we said, yeah, we can lower a little bit our performance requirements for the editing part. It can be a little bit slower, but we don't want to compromise performance when serving a website. Everybody wants their websites to be served as fast as possible. Also in terms of availability. Although our business case says that WIX will lose money if people will not be able to sign up and build their website, but our customers will lose money if their site is not up and running. So WIX is always towards what is best for our customers and less is what is best for us. So our availability concerns is higher on the viewer part than the editor part. And of course, if you look at the read-write patterns, while you're editing your site, you have a lot of writes to the database, and serving the site, you have a lot of reads. So this is basically the two major aspects of our systems. So what we did is we took our monolithic application, we call it MonoWIX, and we extracted a part of it by extracting and saying rewriting, the part of it that is responsible for serving the websites. Everything else stayed in this monolith. The login, everything else stayed there, but we just extracted this one part of viewing the site. But while extracting it, we put a guideline to our developers, and we said, we want completely isolated and no runtime, no deployment, and no data dependencies between those two. It's basically two monoliths, if you think about it, right? It's one big, huge, the old monolith, and we created one new, smaller monolith that is responsible for just one thing. And we wanted nothing between them, no dependency between them. some extent. So what we achieved is basically separation of product lifecycle. Okay, we decoupled the architectures, and now it allowed us to decouple the teams. So instead of having one team working on a big monolith and everybody stepping on each other's toes, now we could create a new team, and this team worked on the public side, and the old teams kept working on the editor side. We gained deployment independence. Remember, most of the changes were on the editor service, the monolith, and less frequent changes were on the public side. And so each team can basically deploy regardless of the other. We also gained the separation by the service level. So now they can scale independently. Well, if you think we have like 95 million users on the editor side, on the public side, we got their viewers. So it's like hundreds of millions of viewers that are coming to look at the sites. So it's a different scalability issue. If we can run the editor on 2 data centers, the public where has a lot of higher availability requirements, we run it in 3 data centers. This one can have maybe 8 servers running the editor, and the public can have 12 servers. It makes it easier for us to scale each one independently. Now we could use different data stores, which are better fit for each use case. Our editor, our sites are built as JSON documents, so we can use MongoDB on the editor side and MySQL on the viewer side. So we're free to choose whatever is right for each of the components. We're not bound to this monolith that everything has to work with whatever, with MySQL, or everything has to work with Mongo. You are free to choose the right technology to solve your problems. And once we chose that, you can optimize the data store for read or write. So denormalize the data on the public side for fast access, for fast read access, while having a lot of indexes and normalizing the data on the editor side, because we have to do a lot of validations and stuff. Already talked about the data centers and the system reliability. Because we have a complete separations between those two, if one service goes down with whatever reason, the other is still up. So if we were on the monolith and we had a bad deployment, the whole system would go down. But now, if the editor goes down, the sites are still being served. They're not affected by each other. You may have a degradation of functionality, which I explain a little bit later, but it's not the entire thing that is going down. And of course, if just half of the system goes down, it's faster recovery time. It's easier to bring up just half of your system instead of the whole thing. So we have those 2 services, and this is how we started. And we learned a lot by just splitting it into 2. So let's go about the things that you will learn. If you think about going to microservices, some of the things that you may learn just going this one small step. So the first thing is service boundary. Okay. One of the most important guideline that we put in place is separation of databases. Every service, every microservice, is this working? Yes? One? Every microservice has its own database. We optimize the data per use case, and you can use different data stores. But now you say, well, if you're editing the site in one part, how would you view it if they don't share the database, right? So we simply copy the data. Okay? So when the user click publish, we copy whatever is necessary. You don't have to copy everything. It's just what is necessary for that service to function properly. And you change the data model in order to adjust it. You denormalize the data and make it, because this has write concerns. You take the data and you adjust it to whatever use case that you need. Now, this comes the question of serialization. How do I actually send the data between those two services now needs to communicate? So we have a lot of options to choose from. Would you choose binary protocol? Is it JSON, XML? Is it over HTTP? Things that you have to consider and choose from. And what's the protocol? What are the trade-offs between those choices? Do you care about readability? Do you care about performance? How do you debug it? What are the tools that are available to you in order to use whatever thing that you choose? How do you monitor it? What kind of dependencies do you create? Do you create a build time dependency? Do you create runtime dependencies? All those questions you need to answer for your own use cases and what is best for you. And now you have two services, right? They are remote. This is a distributed system suddenly. How would you expose the API? Okay, via REST, via RPC, via SOAP, God forbid. You need to make all those decisions. So this is what WIX chose. Okay, we started with a binary protocol. Those days they were in Thrift and all those nice protocols that we have now. So it was something that called Hessian. It was a binary protocol. It was relatively fast, and we were having a lot of problems with it. It was working great until we had to debug it. There was a bug, and we had to debug it, and we couldn't see what is going on the wire. We just saw that one service is making a call to another service, and something broke, and we couldn't figure out what that was. And the tools didn't really exist, and the code was really hard to understand. And eventually, we thought about it, and we said, well, maybe we'll switch to a textual protocol. So we tested JSON, and it turns out that that JSON is a really good library. It's fast, and when we did the benchmarks, we saw this is pretty good, and it's good enough for us. Okay, so we opted for readability and debugability over performance. I mean, if we were Google has chosen performance because this is what they need. For us, for our scale, which is decent scale, it's not Google scale, but it's pretty decent. It's good enough. And so we chose JSON RPC over HTTP for internal communication and REST for external APIs that we expose. So if you're thinking about those APIs, another thing that you need to consider is, what do I do with API versioning? Do I need like an API schema with version 1, version 2? How do I change my APIs? And you're not going to need it. Okay, for YAGNI, for those of you who don't know, is you ain't going to need it. Okay? We're working on one single company. We can communicate with each other. All you need to do is save yourself a lot of trouble and keep it backward compatible. Okay, if you add a parameter, just ignore the unknowns, communicate to everyone, okay, this is how it's going to work, and just save yourself a lot of problem with maintaining multiple API versions, which you will have a hard time to deprecate it. Another thing that it makes us easier is, I mean, we're working in a continuous delivery environment. We're doing like 100 deployments a day. So we get an alert for every service that hasn't been deployed in the last 30 days. So it takes about 30 days for everybody. This is the time that we said, okay, you have 30 days until you need to switch to this new API. If you want to deprecate something, you can create a new method and tell everyone, hey, you got 30 days to switch to this new method, and then I'm gonna, it's RPC, it's easy, it's just a method call. Doing external APIs for the internet, for the public to consume, it's more strict, so there maybe you need to do the API versioning, because if you put something out there, you can probably never get it back. You can never deprecate it, or it will take years before you can do it. So it may make sense there. So let's talk about asynchronous calls. So these are synchronous calls, of course. Asynchronous calls. So when we had the monolith and we had asynchronous operations, but now we have a distributed system, right? We got 2 servers. What should we use? You hear about a lot of buzzwords about Kafka. Should we use RabbitMQ and ActiveMQ and whatever MQ because we want to what? What did we do when we had this monolith? We used threads, right? Simple. So you ain't gonna need it. Not to begin with. If you already had queues in place, by all means, use them. But you don't need to add another layer of complexity to your system. This is a distributed system. Everything that you add has a DevOps cost. Somebody needs to understand, somebody needs to maintain this queuing system, this new middleware that you just introduced. It creates a lot of overhead for your teams if you don't really need it. If you actually need it, if you have a use case and business case that needs it, put it there. But don't put it just because now you got 2 services that need to talk to each other with an asynchronous call. Threads are good enough. Now what about service discovery? You hear a lot about service discovery, right? Microservices, how do one service discover the next service? You can use Zookeeper. Who here didn't hear about Zookeeper? Console, etcd, Eureka, a lot of cool toys that companies like Netflix and Twitter and Google, they're all coming up with these new cool toys. And now you got a distributed system. You got 2 microservices that you need the cool new toys. How would one service find the other service? Right? You don't need them. Not when you start anyway. When you have hundreds of services, remember those companies, they have hundreds and thousands of services. They develop tools to help them solve the problems that they have. They're not, it's a different scale. But when you start, you don't need to think about it. You can use IP addresses, configurations files, load balancer, DNS, whatever you have already in place in your production environment, keep using it. WIX is using configuration files for, until we had like around 100 microservices, we were still using configuration files, and you have the load balancer that knows these are the services and that's it. Okay? Load balancers are doing great job. You don't actually, in most cases, you don't even need client-side load balancing. Okay? If you have load balancers in place, just keep using them. Keep it simple. Because you have a lot, the learning curve in doing microservices right, you will fail when you start, you will fail, you have a lot of problems. So you need to keep it to minimal as possible, okay? Keep the complexity low. Now resilience. Let's talk a little bit about resilience. Now this is a distributed system. When you see one service is making a call to another service, and we have this nice arrow. It's a nice architecture, right? What does this arrow mean? Okay. So what does it mean? Data flow, replication. It could mean anything, right? But in a distributed system, when you see an arrow, the first thing that you need to think about, this is a failure point, okay? When you're doing a method call inside a monolith, running on the same JVM, you're calling a function, the function will get called and executed, okay? Unless their whole service goes down, when you make a function call, a method call, it will be executed. In a distributed system, when you make a method call, which is translated to an RPC call, I can guarantee by 100% that at some point it will fail. Okay? And you really need to think about it to understand it. Every network hop, you're going outside the network, every network hop reduces your system's availability. It's not a big deal. There are ways to overcome it. Okay? But You need to understand and really be careful in how you mitigate those failure points. And there are things that you can do. You can do a retry policy. Okay, if you failed once, you can retry. One retry will solve most of your problems. Okay, usually one retry is good enough. But you should really think about it. What operations you are allowed to retry? Okay, if you're a bank and you're withdrawing money, and this operation withdraws, you don't want to retry this operation 5 times. It's not good. So only on idempotent operations you should do a retry. Circuit breakers and throttlers. Okay, if one service goes down, you want to do a fail fast, but then you have to tweak it. How many failures should I circuit break? Okay, if it's on the first failure, you will create your own downtime. Okay, if it's on the 10,000 failures, probably you'll bring your system down. So those are the things that you need to tweak, and they're different between each system because each system has its own requirements and its own data flows and throughput and whatever. These things you need to tweak and understand how they work for you. But the good thing about this failure point that we have is you can actually now create a degradation of service instead of a complete downtime. Okay, so if one service goes down, it's just one service. So you can create feature killers. So you say, okay, if let's say the publishing service goes down, you can flip a switch and you say, okay, currently publishing is not working, but you can do all the other things. Okay, so you can have nice messages to your customers, and they continue to work instead of getting a whole downtime. This small part currently doesn't work. We're fixing it. Go do some other stuff. You can employ fallbacks and self-healing mechanisms. So, for example, one thing that we have when you publish a site, okay, this is in our use case. When you publish a site at Wix, you get a URL. URL is construct from your username as a subdomain, .wix site, and then your site name. How do we get the username? We get the username by taking the session, going to the user server, getting the latest username from the user server, and constructing the URL. Now let's say if the user server is not available, what do we do? Do we fail publishing? Then we can have fallbacks. So let's say the username is also stored in the session. So it's not, maybe we will lose consistency, maybe if the user just renamed its username on a different computer and we didn't update the session cookie on that browser, maybe you'll get the wrong URL. Next time you'll get published and the user server is up, we will fix it. So it's a kind of self-healing. Self-healing is really dependent on whatever use case that you have. But you can think about it and make your system more resilient. Let's talk a little bit about testing. When you're testing a monolith, it's easy. Right? You have the unit tests and maybe integration test, and that's it. You're done. In a microservices architecture, the testing becomes more complicated. Okay, this is the price that you're paying. You're paying one of the prices that you're paying, right? So this is how we do tests. Okay, this is kind of during the years, this is what works for us. So we do the unit tests like everyone else. And then the next level of test is we're doing integration tests, but we're doing integration tests that includes the serialization, okay, until this point, until this service. So we are creating simplicators of the services, and we actually testing also the serialization. We try to do it before that, and we saw that we actually it's better for us to actually test the serializations. The next level is we're doing a server end-to-end test, when we're running the server, and everything is running in memory, right? It's during the CI, it builds, it takes all the databases, make them embedded databases, running all the services in memory, and continue. And the next thing is automation. The automation runs every night. We don't wait for automation to be done. Once the end-to-end test runs, we deploy. We don't wait for automation. Automation is mostly for client-side code. Now, what about distributed logging? Now we have a distributed system, right? So we need distributed logging. Logstash, Kibana, whatever. You ain't gonna need it. Not at first. Actually, we at WIX, we don't really like logging. We don't believe in them that much. Show me the one person that know how to write a decent log file and didn't copy something from the internet. This is the logback XML, take it and hope for the best. So this is where the DevOps part comes. When you're having a microservices, everybody has to have easy access to production, understand what that is. So we built into our internal frameworks that every microservice is built on. We built metrics, which every developer can go in the web interface and can understand what is going on with their service. You can have performance metrics, the last exceptions, how are the queues going, what is the experiments that this service is run. Every service has this exposed to the developers. In very rare cases, we need to go to the logs. Logs are mostly for forensics. Now let's talk about the ownership. Who owns the service? Well, a microservice is owned by a team. Okay, it's not like a dead code that can be dead and you can rewrite the code. This is a real production environment that is live. Okay, you build it, you run it, the team owns the responsibility. Otherwise, people cannot go on vacations. Now, if there is a case where there is one person, it shouldn't be, but sometimes it happens when only one person knows the service. When this person leaves, the responsibility on the service can be in two cases. One, if the person goes just to another team, this person can take the microservice responsibility with him to this next team, or the responsibility on these microservices stay with the team, okay? But nothing gets left behind. This is another thing that we have also with the continuous deployment alerts that we have. Every 30 days, everything has to be deployed by their owner. So if nothing gets deployed, we get an alert. So what is the right size of a microservice? Everybody asking this question. Kind of a stupid question, if you ask me. I'm going to give you a stupid answer. So the size of a microservice is the size of the team. Okay, you have big teams, you'll get Monolith. You get small teams, you get small microservices. We have many teams, you get a lot of microservices. Okay, everybody wants to be independent, nobody wants coupling. So look about all those things that we had to learn and understand and get experience. We just separated it into two monoliths, basically. So we learned about service boundary and how to monitor and the infrastructure and the SLA and the API definition and the testing and compatibility, backward and forward, a lot of things that we have to learn just by splitting it into two. So we took this methodology, this road, and we continued to extract more and more microservices. But we actually like the definition of this is the editing part and this is the viewing part. And we make them, instead of two services, we make them into segments. So this is basically a quick look and partial look on how WIXs look like. So for every microservice, a new microservice that we have, we actually ask our developers, okay, which segment that this belongs to? And each segment defines some kind of criteria of an SLA. So if it's an editor segment, you got mostly rights, and it has to run in 2 data centers. And it has to be in a database that is replicated like active standby. You can do active, it's better, but this is the minimal requirement for your service. If your service requires more, then it's a public service. So it has to be in at least 2 data centers. And databases have to replicate it active as many data centers that we have. And your uptime is probably higher than in the editor segment. And these questions we ask the developers, we ask the product managers, the product. Okay, what do you expect from your service? And it helps the developers understand which segment does it belong to, and here are the guidelines for what are you gonna develop. And if you think about, hey, I actually need this, but I also need this, it's a good hint. Maybe you should split it into 2. One part will be in the editor segment, one microservice will be in the public segment. So now the question is when to extract a new microservice. Okay, your program is evolved. Should we extract a new library, or should we create a new library, or should we create a new microservice? We need to extend the functionality. So this is an example. Let's say I want to have a time zone service. So given an IP, I need to get the time zone. So there are concerns about performance. I need to get the IP, I need to get the time zone, calculate things. What should I do? So we need to ask ourselves some questions. Do I create a deployment dependency? What overhead do I create by implementing this? Who owns this library or microservice? So in this case, if you had a chance to work with these tools, so given IP, you need a database. We use MaxMind, a database that lists all the IPs and give you back the time zone. So if I create a library and every microservice will have to embed this library in it, then who owns the database? When the database needs to upgrade, I need to upgrade it in many microservices. So who owns it? So it gives us a good hint that, hey, maybe this is a common service. It has a DevOps overhead. So in this case, we will create a microservice. So the rule of thumb, it's a guideline, it's not a rule. Okay, usually microservices have ops. Okay, it's not a library. Library is usually computational only. So you create just a build time dependency, but not a runtime dependency. If you create a runtime dependency, you should strive to decouple it. Okay, this is microservice. It has its own team that's managing it and taking care of it. Now microservices can, in theory, you can create in any stack. So you have multiple teams. Anyone can add, okay, I need Kafka and I need Mongo, and this one wants MySQL, and the other one wants Hadoop, and this one wants Akka and Cassandra. So a lot of things. Anybody can use anything, right? In theory, yes. In practice, some people actually do it. I highly recommend not to. Okay, use standardization. Okay, when you use standard middleware, the organizational knowledge is spread around many people. If every team will pick their own technologies, and something bad will happen, remember there's a DevOps overhead with those things. If something bad will happen, the only team that can handle this problem is the team that owns it. Okay, nobody else can help them. If it's a small team, if it's just 2 people decided, okay, we're gonna use Cassandra for this thing, and they're the only one in the organization that use Cassandra, and one of them is on vacation and the other is not available, then your system is down. Okay, so try to have standard stacks. You can innovate. It doesn't prevent you from innovation. If the standard stack doesn't solve your problem, then you can have an innovation in a team that said, okay, I have a real use case. It's not because it's cool and I feel like it and because I want to learn something new. It's because I need to solve something that the standard stack doesn't give me. And then you can solve the problem, the team takes ownership, create it, and then it expands to more and more team if they have use cases that need the same technology. Same goes to programming languages. In theory, you can develop microservices in any language. I highly recommend keep it very, very short list, okay? Because you have cross-cutting concerns. If everybody will implement it in their own language, you will lose the ability to reuse code. If you have something like session management, this is a library that everybody has to have, and you want to upgrade this library or change the encryption algorithm and stuff, everybody that use something will have to re-implement the same thing, and you'll have bugs in one, and you don't have the bugs in other, and you have compatibility issues. You will have a lot of problems going forward. Remember, maintainability is a key issue here. Okay, you can write it, but it will be very difficult to maintain it the more stacks that you add to your system. In Wix we have basically a Scala Java stack, and only now we're introducing another Node.js stack, but we know the price that we're willing to pay and all the trade-offs that we're making. So we're implementing our framework twice, and this was a conscious decision. It's not because somebody doesn't like Scala or Java. It's because we actually have a need, and we thought about it and say, okay, we're willing to pay the price. So keep it simple. Reduce the cost of a new microservices. When you're building all those infrastructure in place, every microservice that you add should have less cost in introducing it into production than the previous one. Now we can, in Wix, we can create a new microservice and deploy it in about 20 minutes. 20 minutes from the person to start, the microservice can run in production. So other things that you need to learn, we're almost done, is how to handle distributed transactions, how to do system monitoring, distributed traces, the trade-offs of a new microservices, deployment strategies. Sometimes you have the dependency in deployments, cascading failures, and how and when to split the teams or build new teams. So, to summarize, every microservices has a DevOps overhead. You need to remember that. And it's all about trade-offs, okay? Don't use whatever you don't need. Think about the overhead that you're gonna incur later on in the process. A lot of times, Monolith is a very good solution. Don't think that if you're doing a monolith, you're doing something bad. If a monolith is constructed in a good way, it has a good architecture, good software engineering, it's perfectly fine. If when you get to the scalability issue, then think about splitting it. But if you don't have a problem and you just think about, hey, microservice is the cool new shiny thing, don't. If it works for you, keep it this way. And don't think that microservices will solve all the problems. Monolith is a big problem. Microservices has a lot of other small problems. So, thank you. This is time for questions.